Okay, question. What are the Lewis structure and VSEPR model of CHO2 minus? Okay, so when writing out the Lewis structure, we first need to find the total number of valence electrons for this ion. So let's calculate it. So carbon has 4 valence electrons. Hydrogen has 1. Oxygen has 6. And there are 2 oxygen atoms, so we multiply this by 2. And lastly, this ion has an overall -1 charge. So we know we need to add an additional electron to this electron count. So if we add all these up, we should get 18 valence electrons. So now let's draw carbon as our central atom. And then I'm just going to draw out single bonds to 2 oxygens and 1 hydrogen. So notice that carbon doesn't have a full octet yet, so I'm going to make one of these oxygens double bonded, and then I'm just going to fill in all the valence electrons. And then we can count out all the electrons to see how many I've drawn so far. So each bond contains 2 bonding electrons, and there are 10 in the form of lone pairs. So we have our 18 electrons drawn in this structure. So now at the bottom, I'm just going to calculate the formal charge of all of my atoms just to see which one carries that negative charge. So the equation for formal charge is the number of valence electrons minus the number of non-bonding electrons. So these are all the electrons that don't participate in the bonding, such as the ones in the lone pair. And this will be minus the number of bonding electrons divided by 2. So first, let's find the formal charge of hydrogen. Hydrogen has 1 valence electron. There are 0 lone pairs, and there's only 1 bond to hydrogen, so there's 2 bonding electrons divided by 2. So it has a formal charge of 0. For carbon, there are 4 valence electrons, 0 lone pairs, and there's 4 bonds to hydrogen, so 8 bonding electrons divided by 2. Also get 0. And now let's calculate the formal charge of one of our oxygens, the one that has a double bond. So oxygen has 6 valence electrons. It has 4 non-bonding electrons, and because there's a double bond, there are 4 bonding electrons divided by 2. So the double bonded oxygen also has a formal charge of 0. So now let's do the single bonded oxygen. Oxygen has 6 valence electrons, and there are 6 non-bonding electrons, and there's 1 bond to the oxygen, so we have 2 bonding electrons divided by 2. So we can see here that this oxygen will carry the negative charge. So I'll just label that in. And now the question also wants us to determine the VSEPR model of this ion. So we need to look at our central carbon atom and take note that it has 0 lone pairs and 3 bonded atoms. So now I just need to look up a VSEPR chart to help us find out its molecular shape and electron geometry. So when our central atom has 3 bonded atoms and 0 lone pairs, you can see it has a trigonal planar molecular shape and electron geometry. I'm just going to write trigonal planar. You can see that our carbon is sp2 hybridized. And the bond angles in between atoms are around 120 degrees. Okay, so now let's see what the junior tutor said. In order to find the Lewis structure, we need to determine first the total valence electrons that are participating in the bond formation. So they also got 18. The additional electron comes from the excess from the ion that is represented by its charge, which is -1. After finding the total valence electrons, pick the least electronegative atom, so that would be hydrogen, but since hydrogen can only form one bond, then carbon would make sense to being the central atom. And then you complete the total valence electrons by placing lone pairs on atoms with an incomplete octet. So CHO2- has 3 electron bonding groups and no lone pairs around the central atom, which corresponds to a trigonal planar structure. Yep, so this solution is correct.